This lecture explains how to make the decisions when you run a hypothesis test. There are two different methods that you can use in order to make decisions, whether you're going to reject the null hypothesis or fail to reject the null hypothesis. First, if sigma is known, so what is sigma? Again, sigma is a population standard deviation. If you have information about sigma, you can use a z-test for the population mean. So what is z-test? So z-test for a mean is a statistical test for a population mean. So the test statistics is a sample mean x bar, and the standardized test statistics is z equals to the difference between x bar and the population mean divided by sigma divided by square root of n. Okay, again, z here is a standardized test statistic, and the test statistic that we're using is the sample mean x bar that we get, like the sample mean that we get from a random sample that you're collecting from the population. Okay. And keep in mind that you can use a z-test when the following conditions satisfy. First conditions is the sample has to be random. The second conditions is at least one of the following is true. First, either the population is normally distributed or the sample size has to be at least 30. Okay, so again, you use z-test to test the population mean when sigma is known. So in order to find the p-value for a hypothesis test, the p-values will be the area to the left tail if you are running a left tail test. The probability to the left here. And if you're running a right tail test, then p-value would be the area to the right of that standard test statistic. If you have a two-tail test, then the p-value will be 2 times of the area, right, to the left or to the right of the standardized test statistic. So if you find the z, which is the standardized test statistic, using the z-test, then you can find the probability to the left of this, right? And then you can find the probability to the right of this standardized test statistic in order to find the p-value. And then for the two-tailed test, again, you're gonna use find the area either to the left of this point or to the right of this z-test, then you will multiply it by 2 to find the p-value. So this area here is 1/2 of the p-value. This area here is actually the p-value. And this area here is the p-value. Again, the z here is a standardized test statistic that you find using this formula right here. So once you find the p-value, how can you make a decision? The decision is made using the following rule. You compare the p-value with alpha. Alpha is this level of significance. If p-value is relatively small compared to alpha, less than or equals alpha, you reject the null hypothesis. If p-value is greater than alpha, that means you fail to reject the null hypothesis. And under hypothesis test, the null hypothesis always assume that the mean of the populations equals to the k values that you are testing. Okay. You rejecting the nulls, that mean the mean, right? The mean of the populations that you claiming should not follow this distributions, should be different. If you fail to reject the null hypothesis, that means you do not have enough evidence to reject the claim that the population mean is about k. So p-values will tell you the probability that you will get an extreme values from a random sample, the extreme or more extreme value from a random sample compared to the sample that you already selected. So if the p-value is small, on this side, let's say, for an example, on the left side, the p-value is small, very small. That means where you have a very, very, very small chance to pick another sample that has a higher standardized test statistics, right? All right, so let's do one example. Example number 9. You want to find the p-value for the hypothesis test with the standardized test statistic Z. And then you decide whether to reject the null hypothesis for the level of significance. First example, the level of significance is 0.1. The Z, right, the standardized test statistics is negative 1.32. And again, this standardized test statistics is already calculated using your sample. And you know that this is a left-tail test. So I know this is a left-tail test, then I can draw a normal distributions, right? And then this is a test right here. But you're looking at the area to the left, the Z value. And the standardized test statistic is negative 1.32. That means it's gonna be on the left of the mean, right? So from the Z value, we can find the p-value, right? So p-value is the area to the left of Z equals to negative 1.32. How can you find this? We have learned how to find the area to the left of this Z value using the Z table. And if I go to the Z table, I know that my Z value is negative 0.32. So this is negative 0.3, go to negative 0.32 here. So I got 0.0934. So the p-value is 0.0934. All right. And then now I compare the p-value with the alpha. So right, 0.0934. And then if I compare, is it less than alpha or greater than alpha? I see that it's less than 0.1, which is alpha. If p-value is less than alpha, then your decision will be you're gonna reject the null hypothesis. Okay, p-value is less than alpha, then you reject the null hypothesis. All right, go to the next example here. So you have a right-tail test, and I draw a normal distributions, and I know that I want to shade it the right tail here, and I know that my Z values is 2.46. Okay, and then I can find p-value. Again, p-values is the probability of area, right, to the right of Z equals to 2.46. And I can use a Z table to find. So to the right, that means it's 1 minus the area to the left, 2.46, 2.4 right here, 6 is right here. So 0.9931, 1 minus 0.931, 31. So that would give you 0.0069. Okay. So this is the p-value, and I compare p-value with alpha. Is it less than or greater than alpha? Alpha now is 0.01. It's still less than 0.01, which is alpha. So my decision is still reject the null hypothesis. All right. Now go to the next example when you have a two-tailed test. Two-tailed test. I want to draw a shaded area on both sides. And I found the Z value is negative 1.68. Okay, now I need to find the p-value. P-values in this case, in the two-tailed test, equals to 2 times the area, right? to the left of this t value, of this z value. Okay, well, let's go to the z table, negative 1.68, negative 1.68, which is 0.0465. So it's equals to 2 times 0.0465. Equals to 0.93 and 0.093. And then you're going to compare this p-value with alpha. What is alpha? Alpha is 0.05 and 0.093 is greater than 0.05, which is alpha. So your decision is you're gonna you fail to reject the null hypothesis. So these are some examples on how you're going to use p-values in order to make the decisions whether you reject the null hypothesis or fail to reject the null hypothesis. That's how you use p-value. And then the next method is you're going to use rejection regions and critical values to make the decisions. So besides using the p-value, you can use rejection regions of the sampling distributions to determine whether you reject the null hypothesis. Rejection regions or critical regions of a sampling distributions is the range of values, right? For the null hypothesis is not probable. If a standardized test statistic falls into this region, then the null hypothesis is rejected. A critical value Z0 or T0, depending on which distribution you're using, separating the rejection region from the non-rejection regions. Okay. All right, so let's learn how to find critical values, Z0 or T0, in the standard normal distributions and also in the T distributions when sigma is unknown. So you use standard normal distribution when sigma is known, and then you use T distribution when sigma is unknown. Okay. First, when sigma is known, how can you find critical values? First, you need to use critical values is associated with alpha, which is the level of significance. You need to know what is your level of significance, right? And then you're gonna determine whether the test is left tail, right tail, or two tail, depending on the claims, depending on your hypothesis statements. And then you can find the critical value Z0 following the rules. If your test is a left tail test, then z-score corresponding to alpha is the critical value Z0. So if you have a left tail test, right, then this is alpha, and this value right here, the z-score that corresponds to alpha, will be your Z0. Okay. If you have a right tail test, then this Z0 here corresponds to 1 minus alpha. So the regions, the left regions here is 1 minus alpha, or the regions on the right here is alpha. Okay. If you have a two-tailed test, then the critical value Z0 will correspond to 1/2 of p-value, 1/2 of alpha. The Z0 or the Z0. All right. So we've been sketching standard normal distributions, right? Let's say for the 3 different tail tests. If you have left tail test here, you can find Z0 here, and this is alpha. Then this shaded regions is the rejection region. If you have the right tail test, you have Z0, you have alpha here, then the shaded regions on the right here is the rejection regions. And if you have a 2-tail test, then you will have 1/2 alpha and 1/2 alpha here. So these 2 shaded areas here are the rejection regions. So once you then determine your rejection regions, then you can calculate, right, your standardized test statistic that you get from your sample means. Then you will compare. You can, if the standardized test statistic falls into the rejection regions here, then you're gonna reject the null hypothesis. But if your standardized test statistics Z falls into the non-rejection regions here, that means you fail to reject the null hypothesis. Okay. So let's say if I found Z is right here, then I fail to reject the null hypothesis, right? But if my Z, the standardized test statistics, is somewhere in here, then my decision is I reject the null hypothesis. Okay, let's do the next example. So find critical values and rejection regions for the Z-test with level of significance alpha. Include a graph with your answer. So I have left tail test. I know that the rejection regions has to be on the left, right? And then I know alpha is 0.05, then I just need to find the Z that correspond to 0.05 to the left. I can find the Z table, and 0.05 is gonna be the average of these 2 values. So it's gonna be 1.645. So Z0 is 1.645. Okay. Now, if I have a right tail test, and I know that my rejection regions has to be on the right of the distributions, and I know the alpha is 0.1, then I need to find the Z that corresponding to 0.1 to the right, and I can use a Z table again, 0.1 to the right, that means 0.9 to the left. If it's 0.9 to the left, then I can try to find it here. So I found that this is the closest one to 0.9, and it corresponds to 1.28. So 1.28 is the Z. Critical value. All right. And then if I have a 2-tailed test, I know that my rejection regions should be on both sides, and alpha is 0.01. So the probabilities of each of the side here should be 0.005, right? Because it's 0.01 divided by 2. 0.01 divided by 2 equals to 0.05. And I'm just gonna find the Z that corresponding to 0.05 to the right, or 0.05 to the left. Let's go to the Z table. 0.05, 0.005, 0.0000, right here. So as you can see, that is the average between 2.57 and 2.58. So the average should be 2.575. So the Z0 here is negative 2.575, and the positive value is 2.575. So you have two critical values. The negative one is negative 0.75, and the positive one is positive 2.575. Okay, this is how you find critical values. And again, in order to make a decision, you need to find the standardized test statistic, and then compare your standardized test statistic to these critical values to make a decisions. If your standardized test statistic fall into the rejection regions, then you know that you should reject the null hypothesis. Otherwise, you fail to reject it. That's how you use p-values, right? And the critical values in order to make decisions when sigma is known. When sigma is unknown, then again, as a reminder, when sigma is unknown, you need to use a different distribution. And one of the distributions we can use is the t-distributions or students distributions. And before we can use the t-distributions, again, you need to make sure that some of the conditions should be satisfied, have to be satisfied. First, the sample has to be random. Second, either the population is normally distributed or the sample size has to be at least 30. How can you use the t-test, right? When you use the t-distribution, this is when you use t-test to test the population mean. So the t-test is a statistical test for the population mean, and the test statistics is the same as a sample mean, and the standardized test statistic, t, is calculated using this formula. It's the difference between the sample mean and the populations divided by S divided by square root of n, right? And in this class, you can use critical values to make a decisions. And how can you find, you can use critical values or you can use p-value. But if you don't have a fancy, if you don't have a TI-83 or TI-84 calculator, it's a bit tricky to find the p-value when you're using t-test. So I recommend you just using the critical values when you're using t-test in order to make decisions for your hypothesis test. Okay, how can you find the critical values in the t-distributions? First step is identify level of significance alpha. Identify the degree of freedom n-1, and then you can use this t-distribution table as a following rule. So if you have a left-tail test, then use the one-tail alpha column with a negative sign. So if you have a left-tail test, then your t critical value should be negative, and you want to use a negative sign of it. Okay. For an example, if we go to the t-distributions, I go to the one tail, left tail or right tail. I can use this row here, one tail, right? And then I can use a degree of freedom in order to find the t critical values. And then because if it's a left tail test, then you have to use a negative value that you find of the negative values that you find in this table. For example, if the degree of freedom is 10 and your alpha is 0.05 and you're using left tail test, then the t critical value should be negative 1.812. Negative, right? If it's a left tail test. If it's a right tail test, then you just use the positive value, the value that you find in this table. If it's a two-tail test, then you should use this row here, two-tail alpha. And if alpha is 0.05, then and then if the degree of freedom is n, then your t critical value is negative 2.28 and positive 2.28. So this is how you going to use the t distributions in order to find the t critical value for your hypothesis test when you use t distributions. All right, so if you have Twotailed test, then it's going to be a positive, like this is negative and this is positive. And if you have Twotailed test, then you use the two-tailed alpha and you have one positive and one negative. The negative on the left and the positive on the right for t critical value. So let's do some examples on how to find critical values and rejection regions for the types of t-tests with level of significance alpha and the sample size n. Left-tailed test. I know that it has to be on the left and my t critical value should be a negative number, right? And n is 20, that means my degree of freedom is 19. Alpha is 0.1. This is n, so the degree of freedom should be 19. Alpha is 0.1 and is a left-tailed test, 0.1. So my t critical value is negative 1.32a. All right, if you have a right-tailed test, then you know that your rejection regions here should be on the right and your t critical value should be a positive number. N is 31, alpha is 0.05. N is 31, so the degree of freedom is 30, and then 0.05, one tail right here, 1.697. 1.697 is a positive number. When you have two-tailed test, you know that your rejection region should be on both sides. Okay, and then Tn is 38. Then degree of freedom is 37 and two-tailed 0.01. 0.01 is here, go down here, and I have 2.715. So T is negative 2.715, and you have another T is positive 2.715. Because you have two, your rejection regions are on both sides, then you need to have two different critical values. Negative, one is negative and one is positive. All right, and again, how can you make the decisions if your T, right, the standardized test statistic T that you find using your sample mean falls into the critical rejection regions, fall into these regions here, that means you need to reject the null hypothesis. If your T falls, like the standardized test statistic T falls into these regions, then you fail to reject the null hypothesis. Now let's try the next example. Okay. Test the claim about the population mean at the level of significant alpha. Assume that the population is normally distributed. Okay, so one condition is satisfied, and also assume that the sample is random. You have S, you don't have sigma, so you have to use t-test. And the claim is mu equals to 15. So that means the null hypothesis is mu equal to 15, and the alternative hypothesis is mu is not equals to 15. Okay, and given this information, you know that you are dealing with the two-tailed test because of the difference here. Two-tailed test, alpha is 0.01. I should use t critical value. So the t critical value, T0. So T0 is using t-table. Two-tailed test 0.01 is the alpha and n is 36. So the degree of freedom is 35. And go here. So this is the critical values for this hypothesis test 2.724. So negative 2.724 and positive 2.724. We have it here, negative 2.724 and positive 2.724 is the critical values, right? And then I have to find the t standardized test statistic t. So t equals to x bar minus mu divided by s divided by square root of n. X bar is 13.9 minus mu is 15 divided by s is 3.23 divided by square root of 36. Let's see. Negative 2.04 if I round it to 2 decimal places. So negative 2.04, this is t value, and I know, so negative 2.04 should be here, right? And this standardized test statistic t falls into this regions. It's not in the rejection regions. That means I failed to reject the null hypothesis, okay? And this one here is greater than negative 2.724, right? So I can make a decisions that I fail to reject the null hypothesis. And the null hypothesis is a claim. So that means I do not have enough evidence to reject the claim. At the level of significance 0.01, you can write at alpha equals 0.01. There's not enough evidence to reject the claim, right? You fail to reject the no, and the no is a claim, so you fail to reject the claim. So that means you do not have enough evidence to reject the claim. All right, next example, the claim is mu is less than or equals to 22,500. So that's the null hypothesis, and this is the claim. This is the claim. And then you configure the alternative is mu is greater than 22,500. Okay, and then you can draw distributions, and based on the hypothesis test statement, I know that this is the right-tailed test, right? Based on this alternative test, it's the right-tailed test. If a right-tailed test, then I can find my critical values, right, or p-value. So sigma is known. That means I'm gonna use the test. Well, in this case, I will try to find the p-value and also the z critical value. So first, finding the z0, which is the z critical value. So z critical value will correspond, is the z score corresponds to 0.01 to the right. So it's like using z table. I can find 0.01 to the left and take the negative, right? So which is this one, 2.33. So it should be positive 2.33. 2.33 is a z0, right? Then where is my z? Where is my standardized test statistic? Z equals to X bar minus mu divided by sigma divided by square root of n equals to 23,500 minus 22,500 divided by 1,200 divided by square root of 45. Which is about 5.59. So 5.59, it should be around here, right? Farther away, which is, this is the Z, and the Z0 is only 2.33. So as you can see that if you use the rejection regions, this Z standardized test statistics falls into the rejection regions, then your conclusions or your decision would be reject the null hypothesis using the rejection regions. But if you want to find the p-value, so what is a p-value? So according to the Z, the standardized test statistic, I can find the p-value, which is the probability to the right of 5.59, right? And according to the table, 5.59 is much greater than 3.49. Thus, the p-value should be equals to 0. P-value almost 0 compared to sigma is less than sigma. So your decision is you reject the null hypothesis. And the hypothesis is a claim, so you reject the claim. And you can interpret your decisions as the level of significant alpha equals to 0.01. You have enough evidence to reject the claim that the mean is at most 22,500. Okay. There is significant evidence to show that to reject the claim that the mean is at most 22,500. All right, let's look at the next example. High fructose corn syrup consumptions. A consumer group claims that the mean annual consumptions of high fructose corn syrup by a person is about 48.4 pounds, right? That means you know that the null hypothesis should be equals to 48.8, and the alternative is not equals to. Okay. A random sample of 120 people, that means n is 120. And the mean of the sample is 49.5. Assume the population standard deviation is 3.6, so sigma is 3.6. So then you can use z-test. Alpha is 0.05. At alpha equals to 0.05, can you reject the claim? And the claim is a null hypothesis. They're asking if you have enough evidence to reject the null hypothesis. So using z-test, you can use either p-value or critical value. But first, I want to draw a distributions. Normal distributions, two-tailed test, I have rejection errors on both sides, right? Using alpha, I can find z0. So the area on each side is 0.0025, 0.0025 right here, 2.81. It should be, so the z value is 0.05. So the each of this area here is 0.025. So 0.025 is not this one. It's not 0. The 0.25 should be here. So it's 1.96. So 1.96, negative 1.96, positive 1.96. Equals plus minus 1.96 because it's two-tailed test. So you have two values, one positive and one negative. Now, what is the standardized test statistic z? So z is equals to x bar, which is 49.5, minus mu, which is 48.8, divided by sigma is 33.6, and divided by square root of n, which is 120. Let's see, what z do I have? .13 is my z standardized test statistics. And where is 2.13? 2.13 is here. So it's actually, it belongs to the rejection regions. And your decision is you reject the null hypothesis, right? Okay. So you can conclude that at alpha equals to 0.05, there is significant evidence to reject the claim that the consumptions of high fructose corn syrup by a person in the US is 48.8 pounds. All right. Next example of credit card balances. A credit card company claims that the mean credit card debt for individuals is greater than 5,000. So it's greater. That means this has to be in the alternative hypothesis, right? And the no should be less than or equals than 5,000. You want to test this claim, you find a random sample of 37 card holders. So n equals to 37. And the mean card balance of, so x bar is 1522. Standard deviations, s equals to 625. Alpha equals to 0.05. So s, sigma is unknown. That means you have to use t-test. Before I'm using a test, I want to draw a normal distributions to make sure that this is the right tail test. So my rejection region should be on the right, and this is the claim. Okay, now I can find T0, which is the T critical value. T0 is alpha 0.05 and 37, so 36 should be the degree of freedom, one tail test, and 0.05 on the second column here, 36. 1.688 is your critical value. All right, now I have to find the standardized test statistic T. What is T? Equals to x bar 1522 minus mu 500, 5,000 divided by sigma, divided by s, which is the sample standard deviations, and divided by square root of n. Let's see what we have. You get negative 33.85, which is a huge number, like a very small number, right? The huge negative number. And this negative number here is over here, somewhere on this side. And apparently it's not falling into the rejection region. So your decision is you fail to reject the null hypothesis, right? You fail to reject the null hypothesis. That means you're not supporting the claim. So you kind of support the null hypothesis. So your interpretations should be at the level of alpha equals to 0.05. There is not enough evidence to support. There is not enough evidence to support the claim. The claim that the mean credit card balance of individuals is greater than $5,000. So it's not statistically significant that you don't have enough statistically significant evidence to support the claim by using this random sample of 37 individuals. So again, this lecture first introduces the different methods, right? 2 different methods so you can use in order to make decisions in your hypothesis test. Second, it helps you, it's demonstrated some of the examples on how to run a hypothesis test, how to conduct a hypothesis test throughout all the steps, right? First, you need to come up with hypothesis testing, hypothesis statements, right? Hypothesis test statement, null hypothesis, and alternative hypothesis. Second, you have to determine whether you're using z-test or t-test, right? Depending on whether sigma is known or not. And then you can find, if you're using p-value, then you need to find the standardized test statistic, and then you find the p-value, and then you compare the p-value with alpha in order to make decisions. If you're using the critical values, then using alpha, you can find critical value, and then you can compare the critical value with your standardized test statistic to make your decisions. Again, this is the 2 examples on how to use z-test or t-test in order to make decisions based on the result from your random sample.